So when we're doing this, we're trying to basically break up this one fraction into two fractions that are adding together. So like we're factoring and we're giving kind of like each factor its own fraction. So when we're solving this, we're going to give two variables for a and b. So our first step when we're doing this is to factor our denominator. And then I'm going to set this equal to, and I have two fractions adding together. The first factor is going to be in the first denominator, and the second factor is going to be in the second denominator. And on top, I'm going to give the numerators variables of a and b. So from here, I want to solve for my a and my b. I want to figure out what those are. And in order to do that, I need to get rid of the fractions. So I'm going to multiply every single fraction by the farthest left denominator because that will get rid of all of the fractions. When I do this, the entire denominator for the first cancels out. Just the x minus 3's cancel out for the second one, so I'm left with a and my x plus 2. Then the second one, the x plus 2's cancel out, so I'm left with b and the x minus 3. From here, I'm going to do a little bit of distribution. And now I want to kind of group all of my variables and my constants. So for this situation, I know I have an x on the left side and ax plus a bx on the other side. So that means my 1x has to be equal to my ax plus the bx. If I were to simplify and be able to add a plus the b, it should be equal to 1. So I could divide the x out of everything, so 1 should be equal to a plus b. I can do the same thing with my constants. So 7 is equal to 2a minus 3b. Now that I have two equations to solve for my two variables, I'm personally going to just multiply the top by 3 so that I can eliminate my b's. And so now I can see my a is going to be equal to 2. I can plug that back in so that first blue equation, a plus b is equal to 1. So 2 plus what is going to be equal to 1, and that's going to be a minus 1. So I know my b is going to be minus 1. Now that I have all of this, I'm just going to replace my a and b that I had written at the top with what I now have with the 2 and then minus 1. And this is my final answer. So I've kind of just deconstructed my x plus 7 over the x squared minus x minus 6. And so if I were to ignore the left side and try to get the right side into one fraction, the left side is what it would simplify down to. So we're going to do the same thing with this one. It's a little bit more complicated just because we have a little bit more of something to factor. But the process is still going to be the same. So you can always pause the video if you like, and then press play to figure out if our solutions match. I am going to go through this a little bit quicker without so much of the talking. All right, we do have a little bit of a situation because our exponent in the numerator is higher than the exponent in the denominator. When I talk about exponents, I mean the highest exponent. This means that I have to divide some stuff out, kind of get the whole number, if you will, out of the fraction so that this isn't an improper fraction. And I'm going to use my long division in order to do that. So now this means that I have a whole x that is kind of like a whole number. That was the x that we got at the top. And then in order to write our remainders, we always do plus the remainder over our divisor. So now what I'm going to be actually breaking apart isn't the x, but will be the actual fraction. So I'm only needing to break up the fraction. I don't have to break up anything else. And so when I'm breaking up a fraction and I have something that's more than just a linear term, so I have this x squared in the denominator, I'm going to break up into two different fractions. So for the first one, I'm just going to have a solitary x, and the second will have an x squared. So now that all of my factors have a representation, I'm going to multiply by, again, my largest denominator, the one that's over on the left, in order to cancel out all of our fractions. So here I do have some variables that have x squared. A has an x squared, C has an x squared, but there's no x squared that goes along with it on the left side. So if there's no x squared on the left side, that means it has to have been a 0x squared, which means I can set my a plus my c equal to 0. So something about the a and the c makes them opposites, so when we add them together, we would end up with 0, and the x squareds would have canceled. Luckily, our last one, the only constant was b, and so b is equal to 4, which means I'm going to now start with my middle equation, plug in my 4 for b, and solve for a. So my a is equal to minus 3, and now I can plug that into the a over the top purple equation so that I can solve for c. Now that I have my a, b, and c, I can plug these into that massive equation. This next equation, I'm going to go ahead and factor the denominator. And so here, because I have an x squared plus 1 as one of my factors, I'm going to have to pay a little bit more attention, a little bit closer attention to what I have in the numerator for that part of the fraction. And so in order to account for the fact that I have an x squared on the bottom, I'm going to have this as bx plus c on the top. So anytime we have a variable squared, you're going to have two variables that you're solving for, a b and a c in this case, and that first b is going to have a variable x with it. Now I can do my multiplying. And I now have another situation where I have a cx, but I don't have an x on the other side of the equation, which means c is going to be equal to 0. Now that I have my a and my c, I can just plug in -5 for a and solve for b. Now that I have my a, b, and c, I can plug these into the equation. Now for the last equation that I'm going to do, this one, it can be a little confusing because it looks like we just have an x squared, but I do want to point out that I have a squared on the inside and a squared on the outside, and if I were to multiply all this stuff together, do all my distribution, I would end up with an x to the 4th power, which means I have a higher denominator than numerator when it comes to exponents, so I don't have to worry about my long division. It's not something I have to do this time. So I'm going to go, I don't have to factor, because this is already factored for me. I can't factor x squared plus 4. If it was a minus, maybe I could, but I can't because it's a plus. And so this squared means that I'm just writing it twice. And we're going to treat this the same way that we did the x squared in the previous question. Because I have an x squared in the denominator, that means I'm going to have an ax plus another variable I'm going to label b. In the second equation, this is very similar to when we had an x squared in the denominator. I had an x and then an x squared for the second fraction. We're going to do the same thing here with an x squared plus 4, and then an x squared plus 4 quantity squared in the second equation. Again, I still have that x squared in the denominator, so that means I'm going to have cx plus d as my numerator. All right, so A and B were already pretty much solved for us since I only had one thing with an x cubed and one thing with an x squared. So now I'm going to use those to solve for C and D. Now that I have A, B, C, and D, I can plug all of this in to that equation. I hope you guys found this helpful. If you did, please feel free to like and subscribe. If you feel like this could be helpful for someone else, please feel free to share. Spread the love.